Hello programmers, welcome to the video. So we will be solving today's Leetcode challenge of 10th of October. Okay, so today's question is taking maximum energy from the mystic dungeon. Okay, let's read the question out. So in a mystic dungeon is a village. Okay, and magicians are standing in a line. Each magician has a attribute that gives you energy. Some magicians can you give negative energy, which means taking energy from you. So if giving and taking some energies. So there is given in example number 1, if you see energies are 5 2 minus 10 minus 5 1. Minus 10 means it is taking 10 a unit of energy from you, it is taking 5 unit of energy from you. So you have been cursed. Okay, we have been cursed in such a way that after absorbing energy from magician I, you will be instantly transported to magician I plus k. This process will be repeated until you reach the magician I plus k does not exist. Okay, so let's understand from the first example. We have energy like 5 2 minus 10 minus 5 1 and k equal to 3. So if I start from the 5, I will be instantly transported to k plus 0 plus 5. I is equal to 0 here, like first index. So plus 3 1 2 3. So we will be reached at minus 5. Okay, and then plus 3 again for the next iteration, and it will be out of bound. If it is out of bound, then we are sure that there is no energy to be taken. And what will be our answer? Plus 5 and minus 5, like something from them. Okay, in other words, you will choose a starting point and then teleport to k jumps until you reach end of the magician's sequence, absorbing all the energy during the journey. Okay, so if let's say for example k equal to 1, so we have to jump one position each time. So we have the freedom to choose from where to start, but whenever we start, we will jump one position, then one position, then one position, one position, like k. We will make k jumps and we will calculate the energy. Note that when you reach a magician, you must take energy from them. Okay, so if you are starting from 5 and k equal to 3, you will reach at minus 5. You must have to take the energy from minus 5. You can't say that no, it's negative energy, I will not take. That will not work. Okay, you must have to take energy from them, whether it is negative or positive. You just have to take the energy. And what will be the maximum energy? It will be the sum of all the energies. Okay, so until you are given energy, return the maximum possible energy you can gain. Okay, so we have to sum them up. For the example number 1, they are saying output is 3. How? So they are starting at 2, like energy number, like first index, they will jump 3 position, 1 2 3. So 2 plus 1 3. So total 8 makes we can collect 3 number of energies. For example number 2, if you see, we have minus 2 minus 3 minus 1 and k equal to 2. We have to do 2 jumps. If I start from minus 2, then it will be minus 2 and minus 1, minus 3 energies. If I start from minus 3, it will be minus 3 energy, because after jumping 1 2, we are out of bound. If we are starting from last of the index, then after jumping 1 2 steps, we are out of bound again. So total energy is minus 1 only. So that's the answer. We can gain a total energy of minus 1 by starting it. Okay, okay, so there is some constraint, like we have given 10 to the power 5 constraint for energy, and for each energy we have 1000 to plus 1000. Okay, so if I sum all of them up, the sum will be fitting in integer, because 10 to the power 5 into 10 to the power 3, it will be more maximum of 10 to the power 8, and 10 to the power 8 will be easily fit in our integer variable. Okay, length of k is minimum 1. Obviously we have to do one jump, either it's a length minus 1, so we will jump complete array at once. Okay, if k is more than energy dot length minus 1, then obviously maximum of all the elements is there, so that doesn't make sense. And if k is 0, then we are stuck at that point, we can't move ahead, so that also doesn't make sense. Okay, so I hope you understood the problem. We just have to find the starting point, optimize starting point, from where we can reach to end without reach the end without getting that more negative. We will get more positives, and we are optimizing that we will get the maximum number of energies. Okay, so for this, let me explain you with some example. So we have some energy E1, some E2, some E3, some E4. Okay, something like till En. Okay, we are making k jumps. So what will be the let's say I will choose E1. Okay, so what will be the answer? E1 plus then E1 plus 1 plus k, then E of 1 plus 2k, something like that. Okay, so you are jumping kk elements, you are summing them up. Okay, we can start from E2, and we will do like E of 2 plus k, then we will do E of 2 plus 2k. We are jumping kk element again until we reach end of the index. Okay, out of the array. So we are summing the all of these arrays, and we will do maximum of them. So how much time it will take? It will take like n square time. We are starting from each index, we are going till end. We are starting from each index, we are going till end. Okay, so it will take order of n square, and that will not work because our constraint is 10 to the power 5. Great. So we have to make some smart moves here. Okay, so what smart move we can make? We can run this algorithm something like, if I start from here E9, okay, if I have to include the En last element, I just have to include the n minus kth element, n minus 2 kth element, something like that. We will jump kk behind, and we will reach at the starting of the array. Similar. Okay, and for each E3, like let's say we have this array E3 to En. Okay, at E3, how can we say that what's the maximum? Okay, let me make here E5, E6 and E7, and for sake of simplicity, let's assume k equal to 2. You have to make 2 jumps each time. Okay, so let's say you have to find the answer of E3 starting from E3 to En. That's the array, forget about E1, E2, that's the array E3 to En with k equal to 2. What's the maximum answer? If I can say what's the maximum answer, I will find the E2 answer. How? E2 answer plus E4 answer plus E2, that will be the answer starting from E2. E3's answer, like this array's answer, plus E1, that will be the our answer of first element. Okay, and by doing this, we will take the maximum of all of them, and we will be returning that answer. Okay, so let's begin. Like we can store each of them, right? For E3 calculation, we can store that what will the value of E3 when we will calculate this. Okay, so I will code this problem out in short way, so you will be understanding better after some coding. So int energy dot size, we will take that. I hope you understood like little gist of it. I will explain after coding this problem. It's running in my mind currently, very frequently. Okay, it's called 1DTP like problem. If you see from the topics, I think it will be like prefix sum or array. So it will be like some prefix sum, you can say prefix sum with some strategy. Okay, k jump prefix sum. Okay, so I am calling it 1DTP. It's easy to calculate. Okay, so let's make a vector. And also, sorry guys, I don't have my pen with me, so I'm not able to explain with the drawings. You have to bear with some comments here. If there is any issue, I can explain that with the pen by tomorrow. Okay, I will take this problem again if you comment so. Okay, so I will take the n size array, and we will fit that we have 0. Okay, all the elements are 0 for sake of simplicity, or we can say all the elements are int main. Okay, we haven't calculated any of them. Okay, so we will take the last element. For example, for the simplicity, let's take the example number 1 as well. So for example number 1, we have 5, we have minus 2, okay, 2, we have minus 10, we have minus 5, and then we have 1. Okay, and for this example, k equal to 3. Okay, so for finding the 5 will say I need answer of 1, 2, 3 minus 5. Okay, for finding the 2 will say I will need 1, 2, 3 answer of 1. Okay, for finding minus 10, it will say I don't need answer of anyone because it's out of bound. Okay, so how we will calculate? I will calculate the answer of, first of all, I will calculate the answer of 1. If I start from here, what will be my answer? Obviously it's sum, because it can't go, it will go after plus 3 points and it will be out of bound. Okay, great. What will be the answer of if I say what will be the answer of minus 5, if you start from minus 5, what will be the answer? It will be the minus 5 only, because if I do 3 jumps, if I do 3 jump from here, 1 2 3, then it will be out of bound. Similarly for minus 10, it will be minus 10, because if I do 3 jumps from here, it will be out of bound. Okay, so now the interesting case. Let's take the example number 2. Okay, what's the answer of 2? 2 plus 3 jumps, 1 2 3 1. Okay, so it's element plus 3 jumps, because 3 jumps is current answer of 3 jump. Answer of 3 jump is 1. Okay, so it will be 2 plus 1 3. And then what will be the answer of 5? Answer of 5 is 5 plus third jump, 1 2 3 minus 5, and then 3 jump, 1 2 3. So all this array's answer is written in this minus 5. So we don't have to go all the way, we just have to go there and tell that if I start from here, what will be the answer? Minus 5, and I will sum it up here. So it will be 5 plus minus 5, which will be 0. Okay, I hope now you get the clear understanding of the problem. So to code this faster, I will do something like, if I am running in the reverse order, loop in reverse order, I greater than equal to 0, I minus minus. Okay, I am running the loop into 0, and I will check if I plus k is in the bound, something I will do, else something I will do, something like that. Okay, if it is not I plus k is out of bound, then we can't do much. Okay, I plus k is out of bound, so that's the answer. So dp of I will be the energy of I, simply. Okay, and if it is in the bound, what we will do? We will do dp of I equal to energy of I plus sum of dp of I plus k, because I plus k exists. Okay, so this is how we can calculate dp, and we can find the maximum element of dp. So for optimizing, we can say we will take a running maximum, and when we will take running maximum, and we will say answer equal to max of answer comma dp of I each time. Okay, we have to do same thing in else condition as well, so better to take this same condition, my bad, and mean outside this if else condition, so it will take always running max of answer, and we will return this answer at the end. Okay, let's run it. Yeah, both the test cases are accepted. Let's submit this. Yeah, so problem is accepted with 143 runtime, memory 151 MB we are taking. Can we do better? So I think you can't optimize more on this linear time complexity, because we have to visit each and every element at least once, which we are doing here. So in that front you can't optimize, but in the space front you can optimize. You can say that we will take the k element only in the dp, so we will make it k size only, and we will be looping through that k size only, because we need current element plus kth one, right? And we will take the maximum of them, something like that. Okay, so I hope you understood the problem. Please comment and subscribe the channel if you like the solutions. We will meet tomorrow again for the next Leetcode challenge. Bye. Happy coding, happy programming till now.